We start with a new topic, Fourier series. What is Fourier series? Fourier series is a approximate process where a non-sinusoidal periodic waveform is converted into sinusoidal waveform with fundamental period T naught and its harmonics. Ft can be represented with some sinusoidal waveform with fundamental period is T naught and its harmonics. Two type of representation is trigonometric, metric and exponential. Fourier series Fs. Fourier series convert the time domain expression into frequency domain expression for a periodic pattern to a discrete pattern discrete pattern. For Fourier series we use some formula. We After Fourier series we found some component in term of omega naught, 2 omega naught, 3 omega naught, 4 omega naught and its harmonics. With the formula Gt or Ft. Ft is a periodic signal. A naught plus A1 cos omega naught t plus A2 cos 2 omega naught t plus A3 cos 3 omega naught t plus and so on. B1 sin omega naught t plus B2 sin 3 omega naught t plus B3 sin 3 omega naught t. Accumulate all the terms, we got the formula. Formula for Fourier series is summation minus infinite to infinite an cos omega naught t and omega naught t plus bn sin and omega naught t. All the terms sine and cos term are accumulated with this formula and some additional term dc term is added to this. So now formula for Fourier series is a naught plus summation an cos n omega naught t plus bn n omega naught t bracket close. This summation is vary from minus infinite to infinite. We include all the term of Fourier series. This formula is In this formula we use different coefficient term. The coefficient term can be calculated separately. A naught is 1 upon t from limit is t ft dt. It is purely dc term, dc value, yeah, dc term of the waveform. Any waveform dc term ft. An 2 by t integration t ft cos n omega naught t dt. Bn 2 by t t ft sin n omega naught t dt. In all three coefficient term a naught, an, bn, all the three terms we use integration with the limit t. It is limit duration. Limit duration means limit is from 0 to t. Limit may be from 0 to t, may be from minus t by 2 to t by 2, minus t by 4 to 3t by 4. any duration of t, duration of t where periodic waveform repeats, periodic waveform या periodic pattern is repeats, its duration is t, it may be vary from minus t by 2 to plus t by 2, minus t by 4 to 3t by 4, any possibility of the waveform. For existence of Fourier series, some condition is there. Convergence of Fourier series. For convergence of Fourier series, some condition is there. Condition is known as Dirichlet condition. Dirichlet conditions. As per conditions, a function ft can be represented with Fourier series for interval t1 to t2. It has finite number of discontinuity finite number of discontinuity and finite number of maxima and minima in the given interval, condition 1. Condition 2 is function ft should be absolutely integrable from t1 to t2. Function should be absolutely integrable, means its value is finite. Area covered by this signal for the interval t1 to t2 should be finite. For existence of Fourier series, signal should be periodic and should be finite. It should be integrable. Now we discuss Fourier series. Basic idea of Fourier series is, for solution of this mathematical expression, we use some symmetry. For symmetry purpose, I repeat this expression, write down again this expression. And Bn sine n omega naught t. I write down again this expression. With the symmetry, we can reduce the calculation. We apply symmetry on coefficient term an, bn and a naught. First we applied even symmetry, type of symmetry. First type of symmetry is even symmetry. Coefficient terms are an equals to 1 upon t ft dt. Second coefficient a naught is an equals to, second coefficient is 2 by t, 1 limit is t ft cos n omega naught t dt. Bn is 2 by t ft sin n omega naught t dt. By applying even symmetry, this term is even. This integration is not further reduced, so a naught have some finite value. an is even and cos is also even function. To multiplication of even function, result will be even, so an is also finite. In bn, this term is even this term is odd, multiplication of even and odd, result will be odd. Result will be odd. Means 0. For even symmetric signal, A naught is present, An is present, but Bn is not present there. Bn is not present there. A not present, An present, Bn is not present. Means conclusion is Fourier series contain DC term plus cosine terms. DC plus cos term only. No sine term exists in even symmetric waveform. Now we applied odd symmetry. With the odd symmetry, this term is odd, this term is even, An is 0. A naught is, this term is odd, A naught is odd. This term is now odd. This term is also odd. Odd multiply with odd, result is even. Means non-zero finite value. For odd symmetric waveform, we conclude Fourier series contain only sine terms in odd symmetry cases. Third type of symmetry is half wave symmetry. In the half wave symmetry, in the half wave symmetry, Ft is Ft plus minus T by 2. It is known as half wave symmetry. In the half wave symmetry, we can't conclude from integration term. We directly conclude it have only odd harmonics of nix of cosine term or odd harmonics of nix of sine term. For odd harmonic waveform, we can draw in this way. This is odd harmonic waveform. This odd harmonic waveform. Ft plus minus T by 2. At this point, if we are moving T by 2 amount, we are exactly negative magnitude as previous. If it is possible, then this waveform have half wave symmetry. If waveform is shifted by T by 2 amount in either of direction, magnitude is just revised, just opposite of previous one. Result is half wave symmetry. Half wave symmetry means only odd harmonics of cos or sine. Let's take example. We took the simple example of pulse train. First I draw a pulse train periodic pulse train repeat after t time period. Fundamental period of this pulse train is capital T. I draw a periodic pattern of pulse train. We want to calculate Fourier series for this. First we have to define the function for a period. Basic idea for Fourier series is first define the function for a period. This waveform is periodic for t duration from minus t by 2 to plus t by 2. I write down mathematical expression for this is 0 for minus t by 2 to minus t by 2 to t by 4 minus. Next a for minus t by 4 to plus t by 4. Last 0 for plus t by 4 to t by 2 plus t by 2. This function is defined in this way. This function is even function by symmetry. Even symmetry. We want to calculate Fourier series. For Fourier series calculation, we have to deal with three coefficients: a naught, bn, an. For even symmetric, both are finite value, a naught, an. Bn is 0. So, with the symmetry concept, we have to calculate only two terms. First, we calculate DC value. What is the DC value? A naught 1 upon t, range is t, ft dt. This is the basic formula for DC value. By putting corresponding to this waveform minus t by 4 to t by 4 a dt, 2a 1 upon t a minus t by 4 to plus t by 4, 2a upon t t 0 to t by 4. By putting value, we get a by 2. DC value of this waveform is a by 2. Next term an. Because bn is 0, we have to calculate only single term an now. 2 by t from minus t by 4 to plus t by 4. Function a cos n omega naught t dt. Now solve this integration. 4 by t 0 to t by 4 a cos n omega naught t dt. Solve this integration. 4a upon t cos, what is the integration of cos? Sin n omega naught t upon n omega naught 0 to t by 4. Further solve this expression. 4a upon n t 2 pi upon t. By putting the value of omega naught equals to 2 pi upon t, cancel with this, and then sin n 2 pi upon capital T small t 0 and t by 4. By putting these two values, we reduced expression is 2a upon n pi sine n pi by 2 is final answer for value of an is. By putting different value of an, 2a n pi sine n pi by 2, by putting different value of n, first I put 0. By putting 0, an is 0. By putting 1, an is 2a upon n pi, n equals to 1. N equals to 2, it is 0. Sin pi is 0, n equals to 2 is 0. N equals to 3, 2a upon n pi minus, n equals to 4, again 0. N equals to 5, again 2a upon n pi, n equals to 6, again 0. N equals to 7, minus 2a upon n pi, n equals to 8, again 0. N equals to 9, n equals to 10, n equals to 11. We got the different value of an. By putting in expression, final Fourier series expression for us is a by 2. It is complete DC value. A by 2 plus 2a by pi cos omega naught t minus 1 by 3 cos 3 omega naught t plus 1 by 5 cos 5 omega naught t and so on. All these terms we get in the answer. Means Fourier series have DC plus odd harmonics of next of cosine terms only. In the conclusion of this